Okay, we want to look at the xz moment, and as we can see, this differs from the others in that we have y times 1 plus y, which is y squared, y plus y squared. Now I've gone ahead and written out the straightforward steps, the steps that are very similar to those we've seen before. We have the y plus y squared in our argument. Our integral with respect to z is not influenced by the y or the y squared, and gives us, as usual, 2 times the square root of 1 minus x squared minus y squared. We've seen that numerous times now. Now, we have to integrate with respect to y. So, what are we going to do? Well, as we've seen before, when we have a product like this, we go ahead and distribute, giving us 2 integrals. The integral of y times the square root and the integral of y squared times the square root. Now, the integral of y times this square root of 1 minus x squared minus y squared with respect to y, we've already seen. So that one is pretty straightforward. So we just say that one, we just proceed in the usual manner. The thing that we have to worry about, or that we have to do a little work to do, is this integral. So let's look at the process of integrating. Now I'm going to leave the 2 off, and I'm actually going to leave the dx off. I just want to integrate from 0 to the square root of 1 minus x squared with respect to y. So for right now, I want to digress and look at the integral from 0 to the square root of 1 minus x squared y squared times the square root of 1 minus x squared minus y squared dy. How are we going to integrate this? Well, how did we integrate this? You recall we just let u equal 1 minus x squared minus y squared, so the du was negative 2y dy. We have y dy here, so our du is just negative 1/2 dy, and this integrates very easily. And you might want to review that, look back at your notes if you've taken notes. But that's a very straightforward integral if you just remember to treat x as a constant. In order to integrate this, we're going to use the fact that we know we can integrate y times the square root by the method I just mentioned. So we're going to use an integration by parts. And we're going to let u equal y, so that du equals dy. And we're going to let dv equal y times the square root of 1 minus x squared minus y squared dy. And from what we've seen before, again, letting, okay, this can be integrated. I'm going to get mixed up with u's and v's if I say it again. So we're just going to say that if dv equals this, then v equals what? It's going to be a negative 1/2 times 2/3 times 1 minus x squared minus y squared raised to the 3/2. So that, using integration by parts, this integral is uv. That's going to be, when this is all multiplied out, this is a negative 1/3 times the 3/2 power. So this is going to be, let's be careful, we're going to get negative y over 3 times 1 minus x squared minus y squared to the 3/2. And again, things are getting a little bit crowded. This is going to be evaluated between 0 and the square root of 1 minus x squared. That is going to be minus the integral of v du, the integral of this with respect to u, which is, of course, du equal dy. This is going to give us, okay, it's going to be minus the integral of this, which is minus, times this. So that's going to end up being plus the integral, still from 0 to the square root of 1 minus x squared of this expression. So that's going to be 1/3. We've already taken account of the negative, times 1 minus x squared minus y squared raised to the 3/2 dy. I'm not sure we've been able to see all that. So just to be sure, we do the integration by parts. If dv is equal to this expression, but with only the first power of y, where the first power of y has been expressed as u, so it's the rest of the expression. If dv equals this, then by a substitution, we find that v is negative 1/2 of 2/3 of the 3/2 power of this thing that's under the square root. Our uv term then gives us negative y divided by 3, negative 1/2 times 2/3 is negative 1/3, times the 3/2 power of this expression. And then it's minus the integral of v du. V itself is negative, giving us a plus. The 1/2 times 2/3 is still 1/3. The du is just dy, and the rest of the expression is just the 3/2 power of our 1 minus x squared minus y squared. So again, recapitulating, we're doing this integral. We have the y plus y squared. We do the integration. We come down to two integrals here. The first of the integrals is regarded as straightforward, or at least straightforward in terms of the examples we've already seen. The second integral is itself integrated by parts to give us this. So where does that leave us? That leaves us with mxz equals. Okay, we'll write down the first of these integrals again. This expression here. So that's going to be 2 times the integral from 0 to 1 of the integral from 0 to the square root of 1 minus x squared of y times the square root of 1 minus x squared minus y squared dy. And then it's going to be plus 2 times the integral from 0 to 1 of this y integral. So that's going to be 2 times the integral from 0 to 1 with respect to x of, again, looking at our last results here, we're going to have the negative y over 3 times 1 minus x squared minus y squared to the 3/2 evaluated between these limits. And I'm going to go ahead and write that in. That's negative y over 3 times 1 minus x squared minus y squared to the 3/2, all evaluated between 0 and the square root of 1 minus x squared. And let's get another set of parentheses out here because we have another integral to write down. And then that's plus this integral from 0 to the square root of 1 minus x squared, etc. And just copying that, we have, let me bring the 1/3 out like I should have before. 1/3 times the integral from 0 to the square root of 1 minus x squared, 1 minus x squared minus y squared to the 3/2 dy. Okay, that takes care of this y integral. So this y integral gives us all of this. And it's then 2 times the integral from 0 to 1 with respect to x, which we've already written, except we haven't written the dx. Now, substituting y equals 0 into this expression, we get 0 because y is a factor. Substituting the square root of 1 minus x squared into this expression for y, again, gives us 0. We're going to have 1 minus x squared minus 1 minus x squared. So this part is going to be 0. All of this, leaving us just 1/3 times this integral. And we pretty much know how to do this integral. So we can write our x moment x z equals 2 times the integral from 0 to 1 times the integral from 0 to the square root of 1 minus x squared of y times the square root of 1 minus x squared minus y squared dy, plus 2/3, 2 times 1/3 of the integral from 0 to 1 of the integral from 0 to the square root of 1 minus x squared of the quantity 1 minus x squared minus y squared to the 3/2 dy dx. We have seen both of these integrals. This integral, if we let y equal the square root of 1 minus x squared sine theta, leads to our cosine to the fourth, or our sine to the fourth theta expression, which we integrated at some length a couple of clips earlier. So this moment has been reduced to something that we should, from direct reference on preceding examples, be able to complete.